Myself Soumya BG, Assistant Professor, Department of ECE, SJBIT. The subject is Basic Electronics. Subject code is 18 ELN 14/24. The textbooks that are to be referred for this subject are Basic Electronics by D.P. Kothari, I.J. Nagrath, Electronic Devices by Thomas L. Floyd. In this session, I will be discussing about the last topic of Module 5, the basic communication system and principle of operation of mobile phone. These are the contents of the Module 5. Let us first start with the first topic, basic communication system. In its basic electric sense, the term communication refers to sending and receiving information from one point to another. The term communication refers to sending and receiving the information from one point to another. Here I have put a block diagram of generalized communication system in this slide. This is the block diagram which depicts the elements of basic communication system. The message produced by an information source is not electrical in nature. Hence, an input transducer is required to convert the message into time varying electrical signal called message signal. The information source which is been producing the information will not produce the electrical signal. So, a input transducer is required to convert that non-electrical signal into electrical signal. In turn, that signal I call it as a message signal. The signal which is in electrical nature is called as a message signal. And at the destination point, one more transducer which I call it as output transducer is required to convert that electrical signal back to non-electrical signal. Electrical signal back to non-electrical signal, and that is done by the help of the output transducer. It will convert that electrical signal into appropriate signal. The transmitter couples the input message signal to the channel. The transmitter couples the input message signal to the channel or the medium. It is a collection of electronic circuits which are designed to convert the message into a signal which are suitable for transmission through the given channel. The basic operation that are performed by the transmitter include amplification, filtering and modulation. The basic operation performed by the transmitter include amplification, filtering and modulation. Amplification is required because the electrical signal obtained from the input transducer, it may be weak. So, in order to convert that weak signal to the strong signal, we need an amplifier in the transmitter. And what is the purpose of filter? The filtering is done to restrict the frequencies of the signal. In wanted to remove unwanted signals, I want filter. Here the filtering is basically done to restrict the frequencies of the signal. Next, modulation is one more task performed in the transmitter. The modulator matches the properties of the signal to be transmitted to the channel through the use of a high frequency carrier wave. The modulator, it matches the properties of the signal that are to be transmitted to the channel through the help of a high frequency carrier wave. Now let us discuss about the channel through which the signal will be transmitted. The channel implies the medium. The channel implies what? It implies the medium through which the message transmits from, through which the message travels from the transmitter to the receiver. The channel implies the medium through which the message travels from the transmitter to the receiver. The channels may be wired, that is using wire communication, or non-wired, that may be using radio communication. If I want to list out some of the examples of wired channels, I can list out the examples as telephone lines. The telephone lines is an example for wired communication. Similarly, coaxial cables. The coaxial cables is one more examples for wired communication. And for non-wired communication, if I want to give the example, I can give the example as air or vacuum, or I can give the example of seawater. Okay, these are the examples that can be taken for non-wired communication. Now, during the process of transmission and reception, the signal gets deteriorated. It gets deteriorated due to superposition of noise into it. As we know, here there is a noise source that is added to the signal in the channel. The noise can be classified into two categories. The noise whose sources are external to the receiver, and the noise which is created within the receiver itself. The noise can be classified into two classifications. Noise whose sources are external to the receiver, and the noise which is created within the receiver itself. If the noise gets superimposed on the signal very severely, the signal to noise ratio becomes very poor, that unintelligible, and they become useless. And in fact, noise may get added to the signal at any point in the communication system. However, the noise adds its greatest damaging effect when the signal is weakest. Now let us discuss about the receiver. The main function of the receiver is to extract the input message signal. It extracts the input message signal from the degraded version of the transmitted signal, which is coming from the channel. The receiver performs again the reverse operation of the transmitter. It performs the demodulation. Again, the signal has to be filtered, so filtering will be performed, and again the amplification has to be done, because when the signal passes through the channel, the signal will become weak. Now again it has to be amplified. So in the receiver, again all the three tasks will be performed: the filtering, amplification, and the reverse of modulation process, that is demodulation. Now finally the signal will be given to the destination. At the destination, the output transducer converts that electrical signal into suitable non-electrical signal of reception. This is about the processes that are involved in the transmission of a signal from the transmitter to the receiver. Next, we will discuss about the principles of operation of mobile phone. Earlier, traditional mobile system was structured with one very powerful transmitter, which is located at the highest spot, which could serve a wide geographical area of radius about 50 km. But the basic concept of cellular system is to place many low power transmitters to cover small area instead of using one powerful transmitter. That is the concept of cellular system. It splits the service area into many smaller area it splits the service area into, that is the cell area, into many smaller areas which are known as cell. You can see in this particular figure, the entire cell area is being divided into many number of smaller areas which we call it as cell. A cell is the basic geographic unit of the cellular system and it contains a low power transmitter. It contains a low power transmitter and its own receiver. A transmitter with a receiver will be present in each cell. The size of the cell varies depending on the landscape and the shape of each cell is usually hexagonal. The shape of each cell will be usually hexagonal because it gives no black spots, and a tower in the cell provides equal signal in the cell. The shape of each cell is usually hexagonal because it gives no black spot, and a tower in the cell provides equal signal in that cell. A basic cellular system consists of mobile stations. It consists of mobile stations, base stations, as well as mobile service switching center, which we call it as MSC. The MSC is also known as mobile telephone switching office, MTSO, mobile telephone switching office. A basic cellular system consists of mobile stations, base stations, and mobile station switching center or mobile telephone switching office. Example for cellular mobile system is GSM. Example for cellular mobile system is GSM, that is GSM stands for Global System for Mobile Communications. Global System for Mobile Communication. This is the full form of GSM. The cellular system operates in the frequency range of 800 megahertz to 900 megahertz, and some of the system even operates in 1.7 to 1.8 gigahertz bands. This block diagram is representing the cellular mobile radio unit. The cellular telephone, sometimes called mobile telephone, is a device by which a user may have a wireless connection to a relatively nearby transmitter. The cellular telephone is a device by which the user may have a wireless connection to a relatively nearby transmitter. The transmitter's span of coverage is called a cell. As the cellular telephone user moves from one cell to another, the telephone must be effectively passed on to the local cell transmitter. Basically, a cellular mobile phone has three sections: RF section, analog baseband processor, and digital baseband processor. This diagram, which is depicting the block diagram of the cellular mobile radio unit, has 5 major parts: the transmitter, receiver, frequency synthesizer, the logic unit, and the control unit. The transmitter is a low power FM transmitter operating in the frequency range of 825 to 845 megahertz. There are 666 3D kilohertz transmit channels. The channel 1 is 825.03 megahertz. Channel 2 is 825.06 megahertz, and so on. up to channel 666 on 844.98 MHz. The modulator modulates the pre-amplified voice signal and the carrier input from the frequency synthesizer. The receiver, here as you can see, this is the receiver, right? The receiver, which is a cellular receiver, consists of RF amplifier, FM demodulator and the filter. An RS amplifier boosts the level of the received cell signal. The receiver frequency range is 870.03 MHz to 889.98 MHz. Next is frequency synthesizer. It is used to generate various signals which are required for modulation and demodulation in the transmitter and the receiver. Next is the logic unit. It is a master control circuit for RF section of cellular phone. Next we have control unit. This is the section which acts as the controller of the input and output of any analog and digital signal. These are the blocks that make up this cellular mobile radio unit: transmitter, receiver, frequency synthesizer, logic unit and the control unit. Let us first depict the block diagram of this GSM system, GSM block diagram. Okay, as I told, in any cellular mobile system, it consists of three main blocks, one corresponding to the base station, another one is mobile service switching center, the third one is mobile station. Here the mobile station is the first one, part. Base station becomes the middle part and the mobile service switching center becomes the third part. Okay, the mobile system is my first part. In the mobile system, we will be having two things. One is SIM, another one is mobile equipment. In mobile system, we will be having two things. One is SIM, another one is mobile equipment. SIM corresponds to subscriber identity module, SIM, subscriber identity module. ME corresponds to mobile equipment. Now we will move on to the next part, that is base station. Now let us see what are the components that are present in the base station. This is my base station. In this base station we have BTS, base transceiver station. Okay, and we will be having another block called BSC, base station controller, base station controller. We will be having base transceiver station and we will be having base station controller, like this. Okay, and moving on to the third block, third important part of the cellular system, which we call it as network switching subsystem. Network switching subsystem, or as I told previously, it can be called by the name mobile service switching center. Network switching subsystem. Okay, in this now let us see what are the blocks that are present. Okay, here we have mobile station switching center, mobile service switching center, MSC, as my main block. With this we have HLR, with this we have VLR, with this we have EIR, with this we have AVC. Like this we have got blocks in this network switching subsystem, which in turn is being connected to the PSTN or ISTN. Now let us see what each block in this GSM block diagram represents. First is let us expand these blocks. SIM corresponds to subscriber identity module, ME corresponds to mobile equipment, BTS corresponds to base transceiver station, BSC corresponds to base station controller. Okay. Next, in the network switching subsystem, VLR corresponds to visitor location register, HLR corresponds to home location register, and MSC corresponds to mobile service switching center, EIR corresponds to equipment identity register, AUC corresponds to authentication center, ISDN corresponds to integrated services digital network, PSTN corresponds to public switched telephone network. Now let us analyze the working of this GSM system. The GSM network architecture consists of three major subsystems: mobile station, base station subsystem, network and switching subsystem. First, let us discuss about mobile station. It is a section of GSM cellular network that the user sees and operates. It is a section of GSM cellular network that the user sees and operates. There are a number of elements in the mobile station, but the two main elements are mobile phone and the SIM, or mobile equipment and the SIM. Here, the mobile equipment consists of display, case, battery and the electronics that is used to generate the signal as well as process the data received and to be transmitted. SIM, that is subscriber identity module, contains the information that provides the identity of the user to the network. SIM contains the information that provides the identity of the user to the network. Moving on to the next block, which is base station subsystem. The base station subsystem of the GSM network architecture is fundamentally associated with communicating with the mobiles on the network. It consists of one or more base transceiver station and base station controller. Each BTS defines a cell and consists of radio transmitter, receivers and their associated antennas in order to communicate directly with the mobiles. A BSC may be connected to a BTS or multiple BTS units, and hence it can be connected to multiple cells. The interface that connects a BTS and BSC, the interface that connects a BTS and BSC, we call it as a ABIS interface. ABIS interface. The interface between the BTS and mobile equipment. The interface between the BTS and the mobile, we call it as interface. And the interface that exists between BSC and MSC, mobile service switching center, we call it as a interface. The interface between BTS and BSE is ABIS interface. The interface between ME and BTS is interface. The interface between BSC and MSC is A interface. Now let us move on to the last part of the GSM block diagram, that is network switching subsystem. It is the core network of the GSM system that provides the main control and interfacing for the whole mobile network. It is the core network of the GSM system that provides the main control and interfacing for the whole mobile network. The major elements of this core network are Mobile Service Switching Office, MTSO, or MSC. It is acting like a normal switching node within a PSTN or a ISDN. It controls the cells and provides the interface between each cell and the main telephone office. It controls the cells and provides the interface between each cell and the main telephone office. Home location register. This database contains all the administrative information about each subscriber along with their last known location. This contains all the administrative information about each subscriber along with their last known location. Visitor location register. This contains selected information from the HLR that enables the selected services for the individual subscriber to be provided. The visitor location register contains selected information from the HLR that enables the selected services for the individual subscriber to be provided. The Equipment Identity Register (EIR) is the entity that decides whether a given mobile equipment may be allowed onto the network by checking its International Mobile Equipment Identity. The Equipment Identity Register is the entity that decides whether a given mobile equipment may be allowed onto the network by checking its International Mobile Equipment Identity. Authentication Center (AUC) is a protected database that contains the secret key that is contained in the user's SIM card. Authentication Center is a protected database that contains the secret key which is present in the user's SIM card. This is about the explanation related to the GSM block diagram. Let us now discuss about the cellular telephone unit. In the next, this is the bibliography of the subject. Thank you.